When most things move in physics, you end up with something having to speed up or slow down. Even if something reaches a pretty consistent speed over time, you usually have to have kind of a build-up to get to that point. And once it ends up stopping its motion, it has to kind of slow down until it runs into a stop. Think of something that falls through the air. So when I throw up this timer, on a drop, there's an instant where it has to be stuck in the air just for a fraction of a second, where it's not moving at all. Okay? It moves fastest when it's just leaving my hand and when it's just about to reach my hand again. And in between, there has to be a point where it completely stops its motion to be able to turn around. Because of gravity and friction, we end up seeing a lot of cases where things have to, what we call accelerate, where they have to move quicker or slow down in order to change their speeds as they go through the motions of things. Hardly ever do you see something just gun it at 30 miles an hour from just a standing still position and then completely dead stop without having to slow down to get there. It just doesn't happen very often. But there are cases where you can have what we call constant speed or constant velocity, where something does keep a consistent speed or velocity all the way throughout. This makes our jobs a lot easier when we're trying to calculate speed or velocity. Then it's just a matter of being able to see how far something goes and in what time. Okay? Now, we've kind of already done this before, where we measure how far something goes and then measure how long it took to get there in time. So your distance divided by your time, or your displacement divided by your change in time, can give you the speed or the velocity respectively. But those have to be the average speed or the average velocity in order to kind of give that little asterisk of, well, it wasn't traveling that speed the whole time. At some points it's going to be moving faster, at some points it's going to be moving slower, and at some points it's not going to be moving at all. It's going to have no motion, just for an instant. So, when we deal with something that actually truly has constant speed or constant velocity, it makes it a little bit easier to describe their motion. And that's what we're going to be looking at today, an example of just constant velocity. We have one of these guys here called the Tumble Buggy. When you turn this on, the wheels start moving. Okay. And when I set this down, it starts to go. So from the moment it touches the ground, it pretty much starts going at a certain speed. It's not very fast, but it starts going. And then however far it goes and how long it takes to get there should be pretty consistent, whether it goes from 0 to 100 centimeters to 0 to 500 centimeters, whether it goes an inch or a mile, it should be going at a pretty consistent rate. Okay? So in this lab, we're going to be measuring the distance and time it takes for this guy to get from one point to another. We're going to do it 5 times, and each time it's going to go a full meter, in other words, 100 centimeters. So there's a couple ways you could do this. You could line up 5 meter sticks in a row and then just have it go down the line on each one. But then you have to be able to stop your timer and start it every time it hit the next meter stick. Okay? Because we want to know how long it takes to get from here to here rather than from here to the end. So that can be a little tricky. Some stoppers have a fancy switch, like a lap button, so that it will start over every time you hit that button. So it makes it easier to kind of say, okay, we start here, we hit the end of this meter stick, lap it, we go to the next one, lap it, hit the next one. It'll give you an individual time for those specific segments. But if you don't have a function like that on your phone's timer or on one of these timers, it doesn't work so well, then that might not be the best option for you. Now, if you're working in a group, you might be able to kind of work it out where you have maybe just 2 meter sticks, and you can kind of shift their positions one after the other. So you can have kind of one here, and so once the car moves past 1 meter stick, it starts to get onto another. You can take the meter stick and move it, but you got to be able to move pretty fast. You got to be able to have multiple people working together so you don't accidentally miss out on timing it and getting the meter stick in the right place and being able to keep track of all that information. Okay. What I'm going to do, since I'm on my own, is a little trick with these guys. We call them Tumble Buggies because aside from just moving in one direction, they can also redirect themselves when they run into a wall. Send this guy towards the wall here to show this off. it turns itself around. Okay? So I'm going to use that to my advantage to have it go a distance of a meter stick and time it, have it hit a wall and turn itself around, so then it comes back the other way towards me so I can track its time on a meter stick again. So it'll go 100 centimeters, I time that, it turns itself around, it comes back for another 100 centimeters, I time that too, and then I'll be able to catch the car and restart it going the other way and keep doing that until I have 5 measurements. Okay? But this is an experiment where you can kind of choose how you want to set it up. You could tape out marks on the floor for your 500 centimeters. Again, you could move the meter stick. You could do all kinds of things to get this done. Okay? It just matters on whether you're working alone or with group members and how you can best kind of coordinate. But this is the way I'm going to do it, is by having it hit the wall and turn around and using that kind of tumble function of the buggy. All right, let's take some data. So I got my timer, got my meter stick, got my tumble buggy. I'm going to have it bounce against my filing cabinet and come back. So I'll time it each time it crosses the 100 centimeters of my meter stick. Stop it. 242. Start. Stop. About 248. Start. Stop. About 238. Start. Stop. About 244. Start. And stop. About 244. So there's my 5 trials. Each time was 100 centimeters of distance or displacement, since we're looking at the change from here to here rather than the total distance of it going back and forth and back and forth. So we had 100 centimeters each time, and we had about 2.40 seconds about each time as it crossed that meter stick.